Thank you, Sahava. Hello, everyone, and welcome to today's webinar, Design Patterns for Scalable Test Automation with Selenium and WebdriverIO. It's featuring Sahas Subramanian, a continuous delivery and quality architect at CDK Global. Again, I'm Bill McGee, and I'll be helping to moderate today's session. As Sahava said, you can submit questions in the chat panel or Q&A box if you're having any technical issues or difficulties. And you can also use that panel to submit questions that you have for Sahas as he goes through his presentation. We'll get to as many as we can in the last portion of the hour. And with that, again, we are recording the session, and once it's out, we'll be sending an email with a link to the recording and to the presentation. But without any further ado, let's get started, and I will be passing it along to you, Sahas.
All right, thank you. Thanks, Bill. Thanks, everybody, for taking time off. I know it's in the middle of the day. Many of you probably are heading out to lunch or coming back from lunch. So let's get started here. So what I'm going to talk about today is about some of the design patterns for scaling your test automation. There are many tools out there. It's fairly easy to get started for a project, for one product. But, what do we do when, what do we do when things go, for scale? So that's exactly what I'm trying to do here. So to set some context, so let's begin let's begin with this, Agile testing quadrants. This is not something new that I am bringing into the table. It's been introduced by our, some of the leaders earlier. The biggest advantage that this way of thinking Agile testing, classifying Agile testing into different quadrants does help us to some great extent to first set some context, zoom out and understand why we do certain testing, why we do certain type of testing, and what is the best way to accomplish the goal that we want, right? So Agile testing quadrant, if you want to learn more about it, I would strongly recommend you reading Agile testing book. I think there are a couple of versions, and so just go and take time out and read about it. But in essence, what they say is like we do all kinds of testing from unit testing, your functional, your performance, and load and security, and everything. But if you want to just classify that at a very high level. Just think about it, what do you see on the left and right? Half of it is to support our programming efforts, our team building, and to reassure that we did not really break anything technically. And half of it is to kind of take the product beyond and see where it breaks and really find that hot spots. So on the left side, supporting the programming, again, that's getting kind of, divided into two areas. One, the primary goal is to figure out, reassure ourselves. As a developer, I checked in some code. I had some functionality working yesterday. Did I break anything? I have a new team member coming in. How do we onboard? How do we learn as quick as possible? And start rolling in. Some of the practices like unit testing, component testing, and that what you see on the left bottom corner are more geared towards to reassure things for the team per se. They're more technology facing, and the other one up top here is more business facing. That is to reassure that we did not break any business functionality. Think like a customer, think like an end user, think from a business perspective. And did we break anything, or did we, how did we, perform, right? That's the space where WebDriver comes into play. Sauce Labs is a great player. Sauce Labs is a great, infrastructure. They offer the infrastructure and take half of the pain from you, and you focus on writing tests. And there are a bunch of other frameworks around, built around Selenium and WebDriver to help us doing that. So that's the focus there is to, reassure whether, whether we break anything from a business perspective, verify our, our product from a business standpoint. That's where WebDriver comes into picture. And so given that context, if you look at the left bottom corner, we're talking about did we build it right, right? That's more about, diving deep into functionality and testing all combinations of, deeper functionality. If you take a specific any specific component, say grid or search, you might want to test various functionalities in that one specific component. So that's to assure, did we build it right? On the other hand, is it working the way we built it? Did we build the right thing? Is where WebDriver comes into picture. So we to answer that question, we would start thinking like the end user, like the customer. So there's the reason I'm bringing in this whole something like a new term, view test, is before, like maybe a few years back, our product or technology architecture, right? We were building a lot of monolith apps. There were no real delineation between your model and view and controller, et cetera. Right? So the UI is heavily tied with your business logic. Your business logic is heavily tied with something else. So it's the only way to test that kind of app is through the GUI. These days, with the evolution of single-page applications, it gives us it gives more control on the UI, where your content, the logic is downloaded once, and every single user action on your UI is has some of the other impact. In order to test those behaviors, we could leverage the architecture a little better than what we could, what we have been doing. Meaning we could test our views and controllers and services in isolation that we do in, at the unit test level. What you're seeing here at the bottom is what typically we do with the WebDriver, right? We access the application from the browser, nothing mocked, everything goes all the way through, it's end-to-end, and often there are many complaints, right? It's not stable, it's flaky, and all kinds of issues. How can we be more smarter about it? Is by kind of introducing this middle layer where you can do more integrated, I call that as a view test, where you're loading your view from your cache, and you could leverage some of the tools like JS-DOM and try to mimic the browser behavior and accomplish most of the deeper down tests what you might do on a given component. So that gives us more confidence about the component. That leaves us to do just like a mile-wide, inch-depth kind of end-to-end test using WebDriver. So that's what, given that context, that's what we're going to focus more on that, where how do you focus more on the end-user behavior and what's going to give us the best benefit to achieve the goal there. That's a little bit of a context. So if you want to learn more about the view test, and in each slides, wherever I can give a reference, I've given it here. You can go to this link and learn more about it. There are some examples and code and everything. So given that, what are some of the patterns that we're going to talk about? The first one that I wanted to start off with page objects, which is very well known in the industry. I would be very surprised if somebody says we don't do page objects these days. And it'll be interesting to learn the reasons behind it. Given that context, right, we do page objects. But then what next? When you start talking about what is page objects, what is the responsibility of your page object? How do you reuse some of the code? How do you reuse some of your tests, right? That's where things get a little flaky, little unclear. So this pattern called chain of responsibility. So the this is typical page object pattern. Wherever you go, you would see this. You have a test at the high level. It could be BDD or TDD. You might use Cucumber. You might use SpecFlow and any tools at that level, unit testing tools. And that'll interact with the page object, and page object will interact with WebDriver, and that goes and talks to the browser, and that's your browser contains your system under test. That's a typical, very, very conventional, typical architecture. What you see on the left is some of the extensions that we might write over time about, for Sauce Labs integration, or for reporting, or for logging, for exception handling, or some, notification or email to run your tests in parallel. A bunch of those extensions, right? So this is given that it's kind of almost wherever I go, I would see this design. Given that design, the responsibility, what I think is like from a test perspective, that's the place to define what needs to be done. And your focus is, again, thinking from an end user perspective, thinking from a business perspective that uses any unit testing tools. And the middle layer where you have test APIs, where that's the place where you define how something needs to happen in your application. We'll see more in detail about it. And then how do you create some of the reusable end user actions so you don't end up rewriting a lot of code. And the extension is where generally I think is, it's a common requirement across all your, whatever common that you find, common needs that you find in your page object and area or in your test that you want to run your test from Jenkins, you want to run this test from Bamboo, and you want to run them in parallel, and you want to send some report out to, say, Allure, or you want to send some reporting logging out to Elasticsearch. You would end up writing all those extensions. That's kind of internally developed and maintained by some team within the organization. So that's kind of the responsibility at a high level. So what is the responsibility of a test, the first one, right, where we write the specification? So you do BDD or TDD, whatever is appropriate, but the objective test should orchestrate the workflow. It will instantiate appropriate page objects behind the scene for you, and then test will tell what needs to be done over to the page object. So now the responsibility is chained over to the next one called page objects. And it'll wait for some response back from the page object. It's going to assert, right? Once the response comes back, it's going to assert, I was expecting to go to Google, and am I in Google website or not? I was expecting to click a button. Did that happen or not? So you're asserting that, and that in the test, and so you have the most information here. You can handle the logging, exceptions, reporting in one place. So the code that you're seeing here, for example, this code is like I'm saying navigate to Google. It's got the logic to navigate to Google, and then I'm saying perform a search. It should search for a product. So literally what it does is like it's got the page object initialized, and it's saying, okay, page object.search, and it's telling me what is the search term that I need to pass it over to the page object, and page object will figure out what is the button, what is the text box, and it'll send the keys, and it'll figure out the element for search button. It'll go and click the search button. If it has to wait for something to, alert to be closed or whatnot, all those things will be handled by the page object, not by the test. That's kind of now, at a very high level, the responsibility of your test. Once we start defining these responsibilities, you might think about like, what is the importance of, why should I really care about this whole responsibility? So the history here is a little bit of history here is like, conventionally, your test automation would have been started by somebody, conventional QA, for example, and then, that one person or two people or how many ever that small team would have been hugging and maintaining that test code. Now, is that enough for you to run as fast as you can? Is it efficient enough in a modern Agile environment? Obviously, no. you want your team to jump in and contribute, you want to build the quality in, and you want the team to own quality. And of course, this test automation is part of quality, right? So how do you engage the rest of the teams? When more people jump in and start doing things, that's where you need to provide some guidance around, here are the patterns, and here's why this pattern makes sense, and here's how we do it. That's where this whole pattern comes into play. So having said that, I also wanted to touch a little bit on this responsibility of a test from a BDD perspective, from a behavior-driven development perspective. There are conventionally like two ways of approaching BDD. You would say, one is the declarative fashion, what you see on the left. The other one is imperative. The declarative, way of approach is it's telling the machine what you would like to happen and let the computer figure it out. In our case, you're telling the page object what you would like to happen, and you're letting the page object figure it out for you. The imperative one is more like you're really telling the machine how to do something. In our case, you're really, your test really tells the page object how to do. It's not really the responsibility of the test. Meaning, instead of saying page.search, you might also say page.whatever is the text box element, and then send the keys, and you can find the search button, and you can go and click on the search button. You can do everything from page object, the test itself. But that's more like you're literally telling the machine how something needs to happen. As a result, it will happen. So it's kind of when something changes, your test is, number one, your test will be super heavy. Like, for example, I have given an example here, the BDD. On the left side, it's more generic, more at a high level. On the right side, it's all more like you're talking all technical terms here. You're talking about when the user enters something in the search box, and you're talking about the enter key. You're talking about the grid. So tomorrow when you refactor your grid to be something else, like your whole UX behavior changes, and you're saying, okay, grid is not as good as we want to go to something like a Windows 10 tiles or cards style. You will end up refactoring a lot of tests where actually the customer behavior hasn't really changed. Customers still wanted to do what he wants to do. Our technical implementation changed, and ideally our test should not be affected by that. So I am more on the side of declarative. That helps us to define the responsibility much more cleaner and stick to it. That's the reason I wanted to kind of bring up this one slide about the test responsibility. Then the next one down the line is page object. So like I mentioned, everybody would say, yes, we have page object, but then when you start asking about what is the responsibility of a page object, what it really does, where do you, when a newcomer comes and when he starts writing a test, he would, where should he do, where should he put in the logic, right? That's when it goes a little unclear. So this is, again, taken from Martin Pfau's talk. There's a link at the bottom. You can go to that website to learn more. But the page object is an API. It is treated as an API for your application. Like here, for example, here it says select album with title, get artists. In my example, I was talking about search. So it's more like your test needs to do something, and the APIs are exposed by page object. Your page object will figure out what are other dependencies that it needs. It needs to load certain, it needs to figure out the UI elements. It needs other page, something from some common repository. So your page object will figure out all those things and will do the job for you. The test is supposed to just go and tell what needs to be done to the page object. Again, another concept here is nicely introduced here is like, now you have abstracted the logic of how something needs to be done from the test. You have done it, most of that is getting pushed into page object. Now, page object needs to interact with your system under test. It's in the browser, and it's all about web elements. So should would it be nice if we can abstract that interaction, meaning searching for the element, finding the element, and waiting for that particular element, and all those element HTML, things, HTML element finding logic. It would be nice if we can abstract that from page object. It's not really page object's responsibility. You can kind of delegate that responsibility to another repository called UI map, where this UI map will serve as an API for accessing all the HTML elements on the page. What this promotes is it's promoting you a standard way to access the element. For example, my team is making a grid component. The member who's making that grid component and the UI architect and the CSS guys, they know the best mechanism to go and reach out a particular cell in my grid. Would it be nice if they can make up the UI map and export that as a reusable component, and your page objects can just go and instantiate that class and get access to that particular element. And tomorrow, when my team refactors the grid to be something else, it's easy for them to go and maintain and update the UI map, which would make the consumer teams who are consuming the grid their job much more easier. So that's another responsibility getting delegated to UI map. So what we're doing here is we're essentially defining a little more, defining the responsibilities a little more clear. I do have some code. I'm going to flip-flop between the slides and code. If you have any questions, just post it out there. We'll get to it at the end. So this is like a theory. How do I do it, right? So for example, I have a Git repo. We'll publish it at the end with the recording. So in that Git repo, so for example, here's the test. My goal is to say Google search, and I want to be able to navigate to Google and perform a search and go and do some shopping from there. So I prefer doing Mocha like a TDD style rather than doing Cucumber or Jasmine. But if you look at it here, I'm using WebdriverIO, and this supports any of those frameworks, Cucumber or Jasmine or Mocha. So you could pick and choose whatever you like. And also, if you look at the architecture and the design that we're talking about, test is really pretty lean. All it does is it's instantiating your page object, and it's talking to the APIs that's being exposed by the page objects. Tomorrow, one of your other team members comes in and says that I don't like Mocha, I like Cucumber, or I like Jasmine. It's going to be a no-brainer to cut over to a new testing framework. So, for example, here what I'm doing here, if you look at it, I am just importing chai, and my container will give me, meaning the container is nothing but a dependency injection, and then the dependency injection container will give me the page objects. So I don't even have a reference of a WebDriver or WebdriverIO or anything that talks to the web app directly. Now I'm instantiating my page objects here from my container, and the first thing I need to be able to navigate to Google, I'm saying, okay, page.navigate. So this is an API provided by my page objects. It will open up the browser, navigate to Google. That's not a big deal. It's pretty straightforward. Now let's assume, so once that job is done, I'm asserting, and then the control moves to the next one. It says, yeah, go and search for my product. So here, this is again the same example that I talked about. So I'm saying simply go and do a search, and for this search term. So as far as the test is concerned, it doesn't know anything more than that. It's all abstracted from the test. So so I have a concrete implementation here. It goes into page objects, not this. All right, so here the search is getting the search term, and it's it's finding the search box and setting the value, and then it's hitting enter, and it's waiting until that job is done, and then it's returning the object back. So that's kind of totally abstracted from the test. And if you go back, how does it find how does it find the search box here? It doesn't have anything to talk to, doesn't know anything about the UI, right? So here, for example, I have another class that's been exported by my UI map that provides me all the UI access to all the UI elements. So I could, in my page object, I could pull in how many ever UI maps I want from different components. For example, here, this is pretty simple in a Google search page. I have a search box and result stats. That's it. And the shopping page has a bunch of other, elements to be provided. So, I'm importing that UI map and using it, instantiating that into my elements, and it's providing me with the search box and result status and everything. So that's kind of a neat structure. Now I can, if I want to cut over to a new technology, even I don't even like JavaScript. I want, we like SpecFlow and C#. It's fairly easy for you to go and rewrite your tests in whatever framework you want, and there should be, like JavaScript executor from C# can execute the same JavaScript, meaning the same APIs, interact with the same APIs, and you're kind of not really affected by changes. So that's a little bit about the chain of responsibility. Moving on, the second one I wanted to talk about is we slightly touched about it. It's more tell, don't ask. So the responsibility of your test here, it's it's orchestrating the workflow, it's doing the assertion, it's taking care of the logging, it's taking care of reporting and all the goodness. So the core logic, if we are writing a declarative style BDD, it will really help us to stick to this model, meaning your test will tell what needs to be done, and the how-to logic is totally kept in the page object like this. And this comes from one of the object-oriented principles. Like if you keep your data and the logic that works, that acts on the data, it's easy for your, for number one, to wrap the head around for engineers, and very easy for maintenance, because when you change your logic, depending on whatever data that changes, it's easy for you to go and change the logic. So what happens here, if the top one is more aligned with the imperative style of BDD, where I'm saying, assume that this is a Google search, right? Test this Google search. I'm saying first call would be to go and find the text box. Second call will be to go and type in the search string. Third call will be to go and find the search button. And the fourth call will be to go and click on that. Instead, if you prefer declarative way of approach, you're putting the logic in here. You're simply saying, go and do a search for me, and this logic will figure out what is the best way to accomplish the job. And over time, you will have a lot of repeated code. You will, across different, you will have a lot of opportunities to generalize your logic, and more code reusability, easier maintenance, and more participation from your engineer, because it's more like an engineering. This is tell, don't ask is nothing specific to test automation. It is a general coding principle, general coding pattern. It will resonate well with your engineers, and you will get more participation from the developers. So again, going back to the code, it's very simple. For example, let me see. Another good example will be here is, so this guy, in this test says navigate to, so it should list relevant products. So when I do a search, what I'm talking about here, let's see. Right, I'm doing a search here. So it should, when I go here, to the shopping tab, it lists all the relevant products. So that's what, this mean, right? Should list relevant product. That means like go and navigate to the shopping tab, which might mean that you may have to wait for the search to complete, and you may have to wait for your, I don't know if you have a spinner, depending on your app, you may have to wait for something to be done and then click on the shopping, and it takes you here, right? That's again abstracted from, that logic is abstracted from the test. It goes to the page object. in the page object, I'm saying, okay, go navigate to shopping tab. So I'm saying wait until this shopping tab becomes available for me, and then just go on click. This whole logic is kept in one place. So that's kind of, that's what this pattern is talking about. The next one, this is my favorite one. Almost 99.95% I see this wherever I go. People put this magic word in almost all the tests. Start using thread.sleep because I don't know, it takes more time to load something. I don't know, it takes 2 seconds, 3 seconds. This is one of the something that we must avoid, in my opinion. This will work once, and second time it wouldn't work, and we will start getting into the flakiness of the test, and we'll start blaming WebDriver, then we'll start blaming Sauce Labs, then we'll start blaming. The blame ball never ends, but the root cause is something like you will have thread.sleep if you go down deeper in your code. So there are, C# and Java, they provide nice wrappers, classes like expected conditions. You can say, I am expecting this particular element to be visible, to be clickable, and before I do something. So try to use that. If you don't have anything, try to make your own wrapper. Please do not put thread.sleep. So for example, what it does is like assume that your test is asking for something to be visible. So your page object library should literally go fetch all the elements from the DOM, get to a specific element that you wanted, and see if it is visible. If it is not visible, keep doing that for like, say, maybe 60 seconds, 120 seconds, whatever it is, whatever is the SLA for in your application, right? So that will make it more resilient. I took this example from WebdriverIO. They have done a really good job on this. So, for example, here what they're doing is like I'm asking wait until a particular element is visible for me. What they're doing is like they're getting the max timeout, like 60 seconds, 120 seconds, and in that time they're checking if it is visible. And they're getting all the elements from DOM, and if this element is not does not exist in your DOM, obviously it's not visible. So go back. If that exists, then they're checking, they're sending a command saying, is displayed commands.push, and that sends a protocol, JSON wire protocol command back to your server and ask whether this particular element ID is displayed or not. And finally, they return the results back to you. So it's essentially what depicted here in this picture. It's a U-turn from here at the end, ideally. Excuse me. So what I'm saying is like thread.sleep is another anti-pattern that we should avoid at any cost. This is a good example how WebdriverIO handles. If you don't like it, just go and at least try to think along the same lines, and you will discover something better. I've been using it for a few months now, and it's pretty stable. I like this approach. And the next one is another important thing is like sharing, meaning at the beginning we talked about sharing the page object, sharing the UI maps, etc. And also in reality, at the beginning we talked about the architecture is changing a lot, right? If you look at the back end, it's from a monolith app, it's going to microservices, nanoservices, and what serverless and whatnot. And the same evolution is happening on the front end too. So your application architecture has changed a lot. The design patterns are changing. You might be adopting something called the UI composition, where you're composing at the UI level, not at the service level, and you're exchanging components between products. If we follow these patterns, what I've been describing, we will be able to share the page objects, share the UI map. For example, the picture here, so if you take grid as a component, these are some of the APIs that I would love the grid component to be exposed for the consumers. Consumers could be product A, B, C, and many, many consumers, right? So what that does is like the consumers do not have to figure out how to test something within the grid. For example, if the consumer is trying to delete a row from grid, they would just pull this down and call this method, and this method knows how to interact with the grid, how to get to that particular row based on the, the row number, and delete that row and return them some meaningful response. It could be the new grid component, or it could be deleted row, ID, whatnot, right? The same way, if you want to get to a particular cell text or column visibility. And so when you think about from a component perspective, if we are consuming a component from another team, it is not only the component, it should also come with its own verification, test automation, techniques, and also the test automation per se. The consumer side, what we will end up doing is like we will pull down their page objects, we'll pull down their UI map and reuse them as much as possible. So, we're trying this, and it's kind of fairly, we're trying to do this as much as possible and working fairly well. That's another pattern that I would strongly suggest thinking about. Now, by doing all these things, you're treating test automation code something equal to production code. This is not, test automation is not something alienated. You're applying all, patterns and practices that you would apply to your production code, and you're treating this as a production code because you're sharing something, you're making something public, and it has to work. And when you refactor that, you have to think about, backward compatibility and all the goodness. So, for example, in my code, how do I share this, right? This is, again, a JavaScript example, but we have done it similar ways for C#. We do NuGet packages for .NET. You do NPM packages for Java. You do appropriately. So, for example, here, I call this as a concrete implementation. That's where all my page object and the logic and UI map, everything exists. And I have set up a build for that, meaning the build will literally, take it, transpile that ES6 code to ES5 code. And we will, lint it. We will, linting is like another code analysis for JavaScript. We will run through JS hint, and it goes through a bunch of, sanity check, and it gives us the feedback. And we'll bump the version, we'll generate a package, and your CI system could pick this package up from here and, publish it to Artifactory. If you use Artifactory, or if you use anything else, it can publish it to there or NPM. And from your test, in my tests package JSON, I am bringing it down like this. Literally, I'm saying, okay, this is my component, pull it down. Once I have this pulled down, my test code has dependency injection. So my test code has dependency injection. It will import all the page objects that are available or that are needed for me from my package. And when my test is asking for home page, this dependency injection library will end up giving the home page object. When my test is asking for a shopping page, this dependency injection will, get the browser from the previous page and instantiate a new shopping page object and return it to my test. So now my test will, for example, here, what happens is my test is simply asking for shopping page, and my dependency injection will go and get the previous, page object, the driver from the previous page, and hand it over to this guy. So, and using this page object, I can continue to write my test. So this right now I have everything in one repo. Need not be in one repo because it's kind of public. This can be published, and this test can be by any team, any product. So by doing this, you're at scale, you're reducing duplicate code, number one. Number two, you're making the maintenance much more easier. Number three, you're making it clear that whoever delivers you a component is responsible to give you tests for that component as well. So, you're kind of building a new practice to, scale your automation and run your automation much more efficiently and bringing more developer participation by doing this. All right, that's enough about it. Now, tooling. WebdriverIO is a fairly new framework out there. It's an open source initiative, and there are many advantages to using this WebdriverIO framework in a nutshell. Meaning, if you remember the first slide that I talked about, we talked about a vertical line called extensions, where you had Sauce Labs integration, you had parallel testing, you had logging, reporting, and bunch of those. And every single organization, wherever I go, something that I see is that custom test automation framework being developed in each organization and being maintained. WebdriverIO takes much of that pain out of us, and it's the biggest advantage is like it's letting us to focus on our core need, which is to automate our tests as efficient as possible, as fast as possible, maintain it properly. So given that, that's the main reason WebdriverIO is kind of standing out. There may be other frameworks like that. WebdriverIO makes it more elegant by supporting ES6. It supports multiple testing frameworks. You can use Jasmine, Mocha, Cucumber, whatever you like. Again, from an assertion perspective, it supports. I use Chai. It supports should and expect. It's ES6 out of box. This is super critical because many of the logic that I talked about, many of the design patterns that I talked about, it's all inherited from object-oriented principles. If a language doesn't support object orientation concepts pretty well, it's going to be very hard to achieve. You could achieve inheritance in a different way in ES5 JavaScript, but ES6 makes it more clear, more easier by providing you a class. For example, here what I'm doing, I'm literally, if you look at my UI map, so UI map is literally a class exported. It's got a getter, and when I call this getter from my page, let's go here. When I call the getter from my page, literally it's going to give me the element ID, and I'm going to be able to access that. So it's going to, it helps implementing, ES6 helps implementing some of the object-oriented principles that we really need in order to be able to stay efficient and scalable, right? And out-of-box promises supported, meaning each and every command is here. If you look at it, I'm not really putting in a thread.sleep, nothing. It's each and every command is synchronized and promises support. The second command will not get executed until the first command's promise is resolved. That is very, it's really huge from test automation perspective. And it's got inbuilt parallel test runner, meaning when you in your test configuration, you can specify. Let me see my config. I'm saying I wanted to run this for multiple browsers. What happens is, looks like oh, there you go, it's hidden here. So I can have multiple browsers. I can have n number of browsers in my capability as long as your Sauce Labs, you have enough VMs for you, and you'll be able to. It'll kick off all the browsers in parallel and wait for them to complete and give you a nice feedback. Then it's got inbuilt Sauce Labs runner part of that, and it's highly extensible. You can extend even handling. I have extended the custom reporter. I wanted to ship something to Elasticsearch, so it was fairly easy for me to extend the reporting capability. And above and beyond, it's got nice API support that I like about it is, for example, we talked about a bunch of the weight-related stuff, thread.sleep, disadvantages, right? So WebdriverIO comes out with some APIs. If you look at it, wait for enable, wait for exist. So they kind of wrapped up as much as possible and provided you nice APIs to make your test code much elegant and short. we're not going to write lengthy test logic. APIs do much of the job. And then it's got a lot of advantages. I was very impressed by WebdriverIO when I started, and it's got pretty good community support. Those guys in Hangout and Gitter, and very responsive. All right. Given that, I don't know. Do we have time to do a demo, or we gotta finish? All right. I assume we have time.
We do have time. Sorry for the getting off mute, but yes, go ahead.
Cool. Thanks. So, so I just wanted to give a quick demo as to show how it works, because so in my test, if you look at my package.json, I have a local test configuration. So it's got inbuilt service for running a local, Selenium standalone. So what all I do, nice. So npm run test local. Sorry, I'm in the wrong place. So what happens is here, it'll start the WebDriver standalone, and it's running the test for me behind the scene, and it's doing the logic what we talked about. And the nice thing about it, it's like I have also integrated this with, in my config, I've also integrated this for reporting. So what I'm going to show now is like it's fairly simple to configure your reporting. So if you go here, I'm saying, okay, I need these many reporters and put them in this place. So Allure reporting, I don't know how many of you know, it's another very good open source initiative that's happening on the other side. So it generated the Allure report for me, and all I have to say, generate Allure results. So it got the results, and it's generating the report. All right, these many times I have run the test, and it's showing me these reports, and I can go to the behaviors. It's not my thing. My example is not really a behavior, but if you do BDD using Cucumber, you will see much better results. It shows me, for example, all 10 tests passed. I can go, say, search for a product. How did that work? It's getting me all the logs right from Selenium. If there's a stack trace, I should see that here. And these are the commands posted to Selenium. This is the result. And it's nicely integrated into WebdriverIO. This is another good thing that I wanted to highlight. Then it's got a bunch of other reports. It also gives you a timeline report and then a nice graph. I would let you guys explore the Allure reporting. That's really good, and it's fairly easy to integrate with any of your CD systems as well. Now, as far as running this on Sauce, I gotta try if it works. I'm running exactly the same test, but I'm trying to run this on 2 different browsers. And all right, let me go back and see. I haven't tried this for a while. All right, I got to see what's broken here, but if I have the GitHub repo here, I will check it out and fix the Sauce Labs issue and check it in. I think that's all I have, and we can look at some questions if there are any.
presentation itself. Sorry. Yes, a couple of good questions, and for the ones that we don't get to, we'll package them up and put them into a blog post. But one is, I'm curious to know how different this framework is than Nightwatch.js. I believe Nightwatch.js uses WebdriverIO and Node in the background. Is that something that you could address, Sahas?
At a high level, I can say there are, like I mentioned, there are tons of frameworks. Almost, you would see a framework coming out every other week, and the space is like much happening space, like DevOps, right? It's a lot of things are happening. So I haven't dealt with Nightwatch.js a lot, as much as I dealt with other frameworks. But what I would say is a good list for you to go back and compare is this. See, from a JavaScript perspective, for sure, ES6 carries a lot of capabilities that will help us to keep our tests, better, stable, efficient, and everything. So go back and, check out if it supports ES6, if it has promises, can it run parallel tests, can it run, does it have Sauce Labs integration, and there's I think there are much more advantages to this framework. So I can talk about this framework and point you to some of the goodness of this framework, and I would suggest you to go back and check it out and compare apple to apple, yourself. Sorry, I haven't dealt with that a lot.
Okay, good. Thank you. Another is it a good practice making my data as hard-coded in the test itself or use some external mode like Excel or CSV?
No. So my suggestion, or what we have been trying that helped us, is we should keep the data outside of test. Test should be an independent, rerunnable, like idempotent thing. It should be able to run when you point it out to any environment. It should be able to run on its own. Your data setup and tear down can happen part of the test, and you would, you have to supply the data from outside. That would be, that'll help you to keep the test clean.
Okay. How about one last one, and then we'll wrap up. This came during the UI map portion at the head of the presentation. Your UI map seems to be using strings for locators. Is that scalable for other languages?
UI map seems to be using strings. Other languages. So let me look at it. So, okay. So I think if we are looking at some of these, I'm just trying to locate them by text, and these are by CSS, and these are by IDs. In general, from a locator strategy perspective, here's how I would look at it. Try to identify a unique identifier. Go with the ID. If not possible, go with some CSS class. If not possible, go with the other way. The last resort is XPath. But when you go with XPath, don't traverse from point A to point B by crossing 10 different elements, because anything that changes in between is going to break your test. So use some XPath strategies like contains that will make your at least the XPath more resilient. You could do XPath, but do more resilient XPath. That's what I would say.
Okay. All right. Well, that's great. Again, I really want to thank everyone for joining us today, and Sahas for a great presentation. We will be sending out an email in the next day or so that will include the links to the GitHub repo, as well as a recording of the presentation itself. And with that, we'll bid everyone adieu and see you on the internet.
Thank you, guys.